attendees are in listen-only mode.
Uh, Good afternoon to all. It's my pleasure to welcome you all to the National Biopharma webinar series. In this series, we are featuring 6 webinars on environment, health, and safety. Today, we are having the third webinar on waste management in biopharmaceutical sector and integrated approach. The National Biopharma Mission is a flagship program of Department of Biotechnology. It is partnering with World Bank with a mission to promote and fund innovate product development and infrastructure building for biopharmaceutical in India. On behalf of National Biopharma Mission, Biotech Consortium India Limited, New Delhi, is coordinating this webinar session. In this webinar, we are having very eminent speakers, and we are having industry experts, we are having policy advisors, and we are very fortunate to have Dr. Sunil Pandey as our chair for this today's webinar. Dr. Pandey is a senior fellow and director for Environment and Waste Management Division of Delhi, and he's having a working as an adjunct faculty and head for Center for Regulatory and Policy Research in Delhi University. He is having more than 30 years of experience in consultancy, research, and management in waste management sectors and its allied areas. And he's holding a PhD degree in hazardous waste management from Nagpur University. So before joining to Delhi, Dr. Pandey was working in ERM India and at Hong Kong University of Science and Technology. With a brief introduction to the chair, I am handing over the section to Dr. Sunil Pandey. So over to you, sir.
Thank you, Dilip, and very good afternoon to all the participants. We are here basically to discuss the recent, state of the art in the sense of what's happening in biopharma sector. And as Dilip said, we have very distinguished set of speakers covering different aspects. So what I'll do is, in beginning, I'll kind of set up the context just to give you some background on what you will be basically getting from the presenters on specific issues. And then I will kind of one by one invite these speakers to share their experience with you. I hope you can see my presentation.
Not yet. Yeah, now we can see it.
Yeah. So what I'll do is, as I said, I'll be setting the context. So I'll not get into very detail of what the biopharma sector looks like. That will be done by my fellow speakers. I'll touch more on what waste management is and why we should be worried about waste management, how waste management looks like in industrial context. So with this very brief background, I'll start my presentation. And as you see, when we define waste, generally most of the time we think that when we say waste is a solid waste. But waste is not only solid waste; it's a solid, liquid, and gaseous waste, and it can exist in any form. It can exist as a solid. It can exist as a semi-solid. It can exist as a gases, also gases carrying particles, so it can be multi-phase when we talk of waste. And as you see, the first bullet here describes tries to give you the definition of waste. And as the definition says, what we discard, especially if you look at the first owner of the material, when he discards the waste, it is defined as a waste, and after its intended use, it's supposed to be disposed or supposed to be treated. Not necessarily waste when it's discarded by first generator, not necessarily requires disposal. Sometimes it can be also used, reused, recycled, which I'll discuss in subsequent slides. And as I said, depending on physical state, waste can be solid, semi-solid, liquid, gaseous, and it can actually, all the waste forms can coexist at any one point of time. And these slides give you, these photographs give you some glimpse of what we're going to discuss in another 1.5 hour session or 2 hour session with you, from the solid waste to liquid waste being discharged, or from how they needs to be treated in wastewater treatment system, on also air pollution aspect on how air pollution issues needs to be addressed. When you look at industry, most of the industry, those of you who are from industry or those who understand basic premise of industry would realize that in industry, what we do is there are certain inputs which are going into industrial processes, and they can be raw materials for the production. They can be energy input, they can be water input, and they then through industrial process result into products. But process is not as linear and as simple as you see in the diagram. There are various emissions or discharges which come out as a waste during this processing of raw materials into product. And the green boxes which you see in these this diagram are basically good practices, which essentially also mean that they are pollution control measures, which are applied either on air emissions. If you look at top, wastewater, when you generate wastewater, you treat it through segregation, through avoidance, and through treatment processes. And the solid waste, again through segregation, you try to separate non-hazardous kind of waste from hazardous kind of waste. And through good segregation practices, you ensure that least amount of most hazardous kind of waste is generated, and all which is generated in the industrial process is treated properly. Wastewater management system, typically, I'll discuss in next few slides how air, wastewater and solid waste are generally managed in industrial systems or in urban systems. This is a very simple diagram of wastewater treatment system. Sometimes wastewater requires pre-treatment. After that, what is generally followed is primary treatment, secondary treatment, and tertiary treatment. The details will be discussed by speakers later on. And the solid waste, sludge which gets generated, has to be processed separately. Sometimes resources, if they are to be recovered from that, they are recovered. And then finally, whatever cannot be treated goes to the landfill for disposal. Similarly, on the gaseous waste coming out mostly from chimneys in industries, there are control technologies which control different pollutants from chimneys, whether they are sulfur dioxide or oxides of nitrogen or particulate matter, or since a lot of solvents also used in pharmaceutical industry, emissions of volatile organic carbon, and these are basically then managed and treated and managed in a way that there's the least impact on health when they are let out from the chimneys. And there are various approaches existing which actually tell you how best we are controlling our air pollution from the industries. Similar approach is for solid waste. Waste is generated. There is a whole stage of waste management chain, which is described by waste handling procedure. Separation of waste into again different waste types. For example, biodegradable separately, recyclable separately, non-recyclable separately. Their storage at source, collection, separation, processing, and transformation. If they need to be processed, then some resources need to be recovered. So transformation and recovery of waste, and transfer and transport of waste. Finally, whatever cannot be processed or whatever cannot be recycled or recovered for final disposal to the landfill site. And these are some example in terms of photographs showing that how typically waste is stored or conveyed to the landfill or conveyed to the treatment processes. Improper waste management, whether it is solid waste or liquid waste or gaseous waste, have caused problem in past. And unfortunately, we are in a season where you would not deny those who are staying in metro cities that air pollution has now become a big problem. And in most of the big cities, people are actually facing the wrath of pollution. These are some photographs which are not very uncommon and familiar. Water pollution case studies in India, sewage discharge in India, gaseous emissions in India and China. very clearly show you that these problems have become real, and if these wastes are not managed properly, then they are already resulting into so much pollution. There are other global problems which not only are exacerbating waste problem, but also are problem in themselves. For example, because of climate change, climate extremes, we are experiencing climate extremes, drought on one hand and floods on other hand. And this photograph, though it's a bit older, but those who are following the recent flooding in Hyderabad very closely would know that this photograph is not very unfamiliar. There were cars and those things washed off in Hyderabad flood as well. Resource depletion in terms of mining, excess mining, resource deforestation, and all this is also, in addition to pollution, is again putting pressure on the environment. Pollution at workplace. This photograph, you'll see electroplating unit, a little older photograph, but just to show you that in industry, if you don't manage your workplace properly, you're not only causing pollution by emission of acidic fumes, spillage, discharges, but also the people who are working there get directly exposed. And as you can see, there's hardly any concept of people using personal protective equipment in this premise where this small electroplating unit is engaged in operation. As a result, what happens is, this is waste oil being stored in a drum, and if you don't stack them properly as a good industrial housekeeping practice, then at some point of time, there's every chance that this can cause pollution. And you can see very well here that there's no price for guessing that this is already causing pollution, and at some point of time, the spilled oil will reach groundwater as well. Similarly, illegal disposal of waste at times, because there are not many industries who don't want to pay for waste disposal to the common treatment and storage and disposal facility. They find it convenient to dispose the waste on the roadside, especially in the night movement of the vehicles. And this also causes havoc to environment. And you can assume that when the rain comes, what will happen? All this will get washed off and cause further pollution. This is a typical case of groundwater pollution. Mr. Kameutra might remember this. There was a place called Bichri village in Rajasthan where a dye intermediate industry was manufacturing a dye. And within a year of their operation, the entire groundwater in that area got contaminated. Fortunately or unfortunately, the area was not used to so much rain. And unfortunately, that year when they started operation, suddenly, there was a lot of rain in that area, and all the sludge which they were storing got washed off into groundwater. And that shows, how we need proper waste management processes, not only to ensure that we don't get exposed to waste, but also to protect others who might not know that their water or groundwater is contaminated. In this case, since it was a dye intermediate, it was immediately noticed that water is contaminated. Imagine if this was not a dye waste water, there was very little chance that it would have been detected as fast as was in this case. This scene is also not very uncommon. You'll always, a lot of times, see water bodies being frothed by discharge of surfactants, by discharge of pollutants, and suddenly you see froth coming. And what will happen is this froth will cover the water, and the penetration of sunlight, which is essential for water body to carry out photosynthesis, for the flora and fauna to survive in water body, that will be cut off, and immediately after some time, it will become a dead water body. So what is basically, if you look at waste management good practices, what is recommended for good waste management practices? is a waste management hierarchy in terms of managing waste, which is kind of what we call a pyramid in terms of what is that. Though what we should have been seeing is an inverted pyramid. But why? This is not inverted pyramid because avoidance is generally not practiced. Waste minimization, though we tell people that try to reduce waste, try to avoid waste generation, but that is not most commonly practiced. Again, if once you have exhausted the opportunity to avoid waste, to minimize waste, the next third best option is basically to look at how you can reuse waste, how you can recycle waste, how you can recover waste. In addition, there's an option also for resource recovery. If your waste cannot be reused, recycled, recovered, then you can use the waste. For example, a lot of energy content in the waste can be used either for energy recovery or can be now what is getting very common is try to use it as a fuel either in the industry or in a premise like a cement kiln where there's a lot of fuel requirement. And in the last, whatever cannot be recovered has to be treated and disposed. Treatment obviously is also below resource recovery option, and disposal actually is a final option. Why? This pyramid is large at the bottom because this is what happens in actuality and not what is desired. Now, I'll try to link this waste management and how good practices in waste management can be adopted by using the concept which is called circular economy. Circular economy, what it means, if you look at the illustration on the right-hand side, most of the time when we look at our production processes, the diagram which I showed you for the industrial operations, it is essentially based on linear economy, where you take natural resources, take energy, take water, take raw material, produce, consume, and when they become waste, either you do partial treatment, full treatment, and then dispose the waste, which is a way we manage the resource in a linear economy. What is desirable and what is now is adopted by most countries, and most countries are trying to build this into their policy programs, is shifting the shift from linear economy to circular economy, where recycling, restoration, rehabilitation, recovery takes a center stage, and no material is allowed to, as far as possible, if they have some value, is allowed to go to disposal at the waste disposal site, essentially minimizing the waste disposal and trying to keep the material in production loop as long as possible. So this is a concept of circular economy. Surprisingly, the concept is not very new. The first time the concept was introduced was in 1990. Though in last 4-5 years, the concept has really gained popularity because of the intense pressure which we are now putting on resources. And we know now that resources are finite, and our demands, if they keep increasing, and if we don't decouple our consumption patterns from waste generation, then we'll soon run out of these resources. So that is why now circular economy has come on center stage in the discussion at all the forums where we are talking of resource efficiency, or we are talking of recycling, we are talking of waste management. It has become a center stage. So circular economy basically is a restorative system which kind of recycles the material to the extent possible and tries to keep that in the loop for production. And there are certain ways in which circular economy is promoted, and these are issues like product life extension, eco-designing of products so that they have a lesser impact on the environment, use of less hazardous material, less hazardous chemicals, long life of goods so that they take time to go into waste stream. Though the manufacturers sometimes don't like that. If you look at cell phones, the typical manufacturer would like people to discard cell phones as fast as possible so that they can bring new products more often in the market. But that's against the circular economy principle. Reconditioning, reusing activities, renting services. I mean, those who are working with offices would now realize that most of the time they don't, at least we do, and I'm sure a lot of other offices as well do. We don't now purchase photocopying machine, or scanning machine, or large office implements, or computers and laptops also as at times, and we like to lease it from the manufacturer. So say after 3-4 years of their useful service life, we return them to manufacturers and they replace it with the new product which is upgraded and updated. And so this type of renting services are catching up, so that you don't end up generating waste at very discrete locations. Waste prevention is also part of circular economy. And industrial symbiosis, where waste material of one process can be either used in the same industry or by another industry as a product, as a raw material, which has been shown very successfully in some European countries. Sweden, for example, is a showcase for industrial symbiosis. These are, not terms which are very unknown, but have become important pillars in promoting circular economy. So overall, circular economy focuses on 3 objectives. Economy, while accelerating growth, it doesn't say that don't grow. Social, as you grow job creation and employment. And environment, which is very important pillar of this. Reduce pollution, and to the extent possible, reduce also greenhouse gas emissions, so that climate is also addressed while implementing circular economy. Waste industry, as I said earlier, is at the heart of circular economy. And circular economy, just a second. Circular economy aims to design out waste and to keep the material which has been generated in the industrial process in the production loop to the extent possible. Circular economy also brings strict differentiation between what is consumable and what is durable component of a product, and how durable component can be designed so that or consumable product can be designed so that they are made for recycling. When they become waste, they can be easily disassembled, they can be easily identified what kind of material they are, and they can be easily recycled hence, or reused hence. There are agencies who have in past estimated the potential for circular economy. There is a report by Accenture Strategy, which is called Waste to Wealth, and they have estimated the circular economy, if once implemented globally, will have potential of generating $4.5 trillion of additional economic output if this is implemented now by 2030. And main aim of circular economy model is basically decoupling economic growth with natural resource consumption, and not only natural resource consumption but also waste generation, so that when you grow, you don't generate the waste in the same proportion and minimize the waste generation. There are countries who have shown that this is possible. For example, Japan has already shown that it's not necessary to generate so much waste while growing. South Korea has shown that. There are other countries who are working very aggressively on benefits of circular economy. Europe has adopted that as a policy principle. China is also going ahead very aggressively on circular economy. So one important pillar of circular economy is recycling. And why recycling is important, the slide shows you compared to waste disposal of the same amount, it creates around 6 jobs. And when you look at recycling the same waste, if it has recycling potential, it generates 36 jobs. And that too, those 36 jobs are at higher level, higher income level, better qualified jobs, and give you more, if you look at livelihood, gives you more income. if you are engaged into waste recycling than other forms of waste management. This slide basically gives you what is a principal recycling industry market potential. Around 1.6 million people worldwide are active in recycling industry, and they together handle around 600 million tons of recyclable waste every year. Globally, the revenue of around $200 billion generated. If you want to compare that, it is similar to GDP of countries like Portugal, Colombia, Malaysia. So, recycling is important aspect. Not only it addresses resource security, but it also addresses, generates revenue. 10%, the smart companies, what they do is 10% of their income, this spend back on R&D, creating high skill jobs, making recycling more and more environmentally sound and efficient. And why it is important? Because material which are obtained from recycling, they meet around 40% of global raw material demand. I would like to acknowledge these are a lot of these slides are produced by UNEP IETC program when we were developing curriculum on waste management for them, and also my former associate David Neby and Associates based in UK. And I'll close my presentation here. I hope I could give you the background in terms of context setting, with a message that to the extent possible, reduce, reuse, and recycle. And thank you. As suggested by Dilip, will take the question answers in the end of the other three presentations. And I'll close my presentation here. Dilip, shall I invite the first speaker?
Yes, sir. You can invite us first.
Sure. Thank you, Dilip. And as you see in the agenda, our first speaker is Mr. J.S. Kamyotra. And Mr. Kamyotra is a close friend and my senior who retired from CPCB very recently. And just to tell you very briefly about what he does is he's alumni of Delhi College of Engineering, and as I said, retired as member secretary Central Pollution Control Board very recently, and has over 30 years of experience on various aspects of policy formulation, environmental standards, developing environmental standards, real-time monitoring network in ambient air quality, water and noise, and also developed India's first indigenously developed mobile air quality van. And he's presently, I thought, sir, you have retired. My apologies. He's presently the director at CPCB and a member of various national policy planning committees. And what we have decided is, to give you, before we go into technical issues related to waste management or integrated waste management, to give you regulatory flavor of what are the regulations which direct a lot of these waste management. And I'll ask with this brief presentation for Mr. Kamyotra to basically share his thoughts with you. Sir.
Thank you very much, Dr. Pandey. Can you see my screen?
Yes, we can, sir.
Okay. So, Dr. Pandey, thanks very much. And in your presentation, you have very rightly highlighted the various issues in management of waste, maybe the domestic waste, solid waste, industrial waste, hazardous waste, all this. But if we talk about the waste, it does not mean that we don't have any legislation. We have a number of legislations to manage the environment. And some of the key legislations we have are the Water Act, which came in 1974 after the Stockholm Conference. And in addition, we had the Air Act, which came in 1981 after the industrialization started. And then as subsequent to this Bhopal episode, we had the Environment Protection Act, which is an umbrella act, which came in 1986. And as the Water Act covered only the water aspects, the Air Act covered only the air aspects, but the Environmental Protection Act cover the entire gambit of environment, solid waste, hazardous waste. You talk about public liability insurance. You talk about anything, even ozone depleting substances, uh, genetically modified microorganisms, storage of chemicals, anything we name, and that can be imbibed in the Environmental Protection Act. In addition, we have a number of legislation to govern the environment, but the important are the three acts which, from the perspective of the environmental protection, directly. If you see the Water Act, it talks about the water pollution. The Air Act, it talks about the air pollution. And then we have the Environmental Protection Act, which talks about many rules, many waste management, hazardous waste. It talks about the ozone depleting substance and many other things. In addition, we have the Public Liability Insurance Act, the National Environmental Tribunal Act, and so on. So many such acts are there which govern the environment. The Environmental Protection Act imbibes nearly many aspects. It talks about the standard formulation. It talks about management of various areas or zone as eco-sensitive zone. And it talks about the noise pollution. It talks about waste management. All the waste management, what Dr. Pandey mentioned, hazardous waste, biomedical waste, solid waste, they are all imbibed under the Environmental Protection Act. And most of these rules have been revamped in 2016. And the battery rules have been revamped recently in 2020. All these rules, waste management rules, they refer to waste as a resource. And that is a paradigm shift. And we see the rules that were existing prior to 2016, where the waste were to be disposed. But now, as Dr. Pandey mentioned, the concept is to reduce, reuse, recycle, recover as much as possible, and then go for the various options available for harnessing the waste that is left, and the last option being the disposal in the land. Then we have the ozone depleting substances, the recycled plastic, and the what we say environment friendly product, the eco mark we have. It also talks about the storage of chemicals. It also talks about accidents, and it also talks about the genetically modified organism, which many of the pharma sector use in the process. And then the major part is the EIA notification, where all the major industries or major projects need environmental clearance from either the center or the state. When we talk about the waste management rules, which have been framed under the Environmental Protection Act, the important one from the point of view of the biomedical pharma sector and the biomed units is the biomedical waste. The e-waste management rules 2016 and the hazardous waste are of more major importance as compared to the other ones, which are also important, like the solid waste management rules. A big unit needs to have its own management of the solid waste. Any new startup going for construction need to look into the construction and demolition waste and so forth. The noise amendment rules and all this are to be also applicable. But when we talk about the clearances required for the project, the first and foremost, any project before it comes, it needs environmental clearance under the Environmental Impact Assessment notification, which came in 2006. This environmental clearance notification is under revision, and the draft was on the website of the ministry. The date for sending the comments or observation has expired. So now the observation receipts are said to be in few lakhs, are being examined by the ministry to see what can be incorporated in the rules, revised EIA rules, and what cannot be. The other important permission that is required, that when any industry or any unit needs to start its operation or needs to establish, it needs to take permission under the Water Act 1974 or under the Air Act 1981. And once the unit has been established, it needs to have the consent to operate, that is the permission required to operate under both the acts. In addition to these acts, the units are also required to take permission or authorization under the various rules applicable to the unit, like the biomedical rules, which are very important for any biopharma unit. And some of the biopharma units also need clearance or authorization under the hazardous waste rules. Most of the biomed facilities which go for instrumentation and all this, they need permission under the e-waste management rules. And some even need under the plastic waste management rule to dispose the plastic material that they generate within their premises or during their operation. When we talk about the environmental clearance, the EIA notification of 2006 clearly defines that the bulk drug units or the active pharma ingredients, API, need to have environmental clearance. What is environmental clearance? If you see, it is a procedure for assessing the impact on the environment, which are likely to result from setting up of a manufacturing units, that is the bulk drugs or API. Schedule of the Environmental Protection Act, EIA, refers bulk drugs and active pharma at category 5F, which require environmental clearance. Now, the clearance is of two types: the projects which are categorized as category A and the projects which are categorized as B1 or B2. In the case of category A projects, the environmental clearance is given by the Ministry of Environment and Forest, by a group or a committee constituted at the Ministry of Environment and Forest at the center level. And then for B1 and B2, by State Environmental Impact Assessment Authority. It depends upon where the project is located and whether it can be considered project A or category B. Even if the project falls under category B1 and B2, and if it is in the interstate border or near a polluted area or reserve forests, eco-sensitive zone, they all come under the category A, and all the clearances are required to be obtained from the Ministry of Environment and Forest. There is a laid down procedure of granting environment clearance, which includes providing the industry requiring to submit an application for which, based on terms of references given by the ministry, and based on the terms of reference, a study is got conducted by the industry or the project, and the report of the project is discussed during public hearing with the public or the stakeholders that are likely to be impacted from the activities of the project. And this activity has to be considered, or the public hearing is conducted by a magistrate level person. And based on the observation of the public hearing, the report is revised and then submitted to the Ministry of Environment and Forest or the state, as depending upon the category of project. And after evaluating the proposal, its impact, the EC is granted by the committee at the center or the state level, incorporating conditions so that the impact on the environment can be minimized as much as possible. Similarly, any industry or project needs to have consent to establish or operate. Consent to establish is at the same time when they go for the environmental clearance, and consent to operate is after the unit has established and is ready for operation. Now, the question comes, who is required to take consent now? So, under the Water Act, it provides for the prevention and control of water pollution, maintaining or restoring of wholesomeness of water. And the Act says that any person who wants to establish or take any step to establish an industry, operation, or for any treatment and disposal system, which is likely to discharge sewage or trade effluent into a stream or well or on land, needs to take consent. When we talk about the discharge point, it can be anything. It can be stream, well, and even on land. So they need to have a consent so that the conditions are imposed which the industry need to comply with. Similarly, in case of air, the Air Act refers to prevention and control of abatement of air pollution. And subject to the provision of this section, no person shall, without the previous consent of the state board, establish or operate any industrial plant in an air pollution control area. So initially when the act came, many states had declared an industry as air pollution control area. But air being dynamic, the impact was felt outside the industrial premises. So then it was felt that the entire state be declared as an air pollution control area so that any activity taking place anywhere in the state is covered under the provision of the Air Prevention and Control of Pollution Act. So once the consent or the EC is obtained, the question comes of the compliance. Now, what is required to be compliant? This is the first compliance which we need to have by any industry or project which is likely to come, is coming up. That is, they have to have the EC or the consent to operate. That is the first compliance. And the second compliance is in the environmental clearance or consent to establish or operate, certain conditions are specified, which may relate to the production quantity, it may relate to the type of fuel to be used, permitted emission quality or effluent quality, water consumption, development of green belt, rainwater harvesting. Even in few cases, it can be technology, or it can be banning of certain category of fuels in that use, or certain raw materials depending upon the site conditions. They may not be allowed to be. Like example, in Agra, because of Taj, no industry is allowed to use coal. No industry is allowed to use furnace oil. All have to use gas as a fuel so that the impact on the monument Taj is minimized. Similarly, the refinery, Matsya refinery, had to have additional control measures, had to have additional monitoring precautions so that the air quality is monitored around the clock. And so the SO2 levels and other gaseous pollutants can be controlled, which can impact the Taj. So depending upon the location of the plant or the industry, and depending upon the air quality in that area, various conditions can be specified depending upon the requirement, site requirement. And the same hold goods when we talk about the water pollution also. Now, once these industries have been established or they have taken consent and the environmental clearance as required, then they have to take biomedical waste authorization if they are requiring it, like the hospitals or the biomed or the pharma sector, the hazardous and other waste rules authorization, and e-waste rules. These are the very common authorization which the units, biopharma units or the biomed units required to take from the pollution control boards. Now, when we talk about environmental clearance, it is given by the center or by the committees at the state level, but constituted under the power vested with the center. But consent to operate and consent to establish is given by the state pollution control boards, because water being a state subject, they are authorized to give consent. And when the Air Act was passed, it was clearly said that the boards managing the Water Act will also manage the Air Act. So the state boards are authorized to give consent. But when we talk about the biomedical waste and the hazardous waste and the e-waste rules, they have been formulated or framed under the Environmental Protection Act. Though authorizations are granted by the state pollution control boards, but they are under the delegation of power by the center. They are only being done once the power has been delegated to the state pollution control board to look into those. When we talk about the biomedical waste from the perspective of the pharma sector and who is required, So first and foremost, it clearly defines the person or responsibility of the people who need it. It clearly says that occupier defines the word occupier. And these rules apply to any person who generate, collect, receive, stores, or dispose or handles biomedical waste. And it can be hospitals, nursing home, dispensaries, veterinary institution, laboratories, any such institute which
So your voice
generate
has gone.
biomedical waste. Yes.
Now
Dr.
we can
Pandey, can
hear
you
you.
hear me?
Yeah, now we can hear you.
Okay. So these rules apply to all persons that generate or institutions or that generate, collect, receive, store, transport, dispose or handle biomedical waste, and which can be any institution, any level, hospitals, nursing home, dispensaries, veterinary institutions, or pathological laboratories. Even the healthcare facilities in schools are covered under this. And all the forensic laboratories are also covered under this. And everybody is required to take authorization under the biomedical rules. Now, the rules are very clear with respect to the definition that who is required, who is a person. It clearly defines the occupier. An occupier is a person having administrative control over the institution and the premises generating biomedical waste. So, which can be anything, a hospital, nursing home, dispensary, clinic, veterinary, anything. And then this occupier has to have authorization from, which means permission granted by the prescribed authority for generation, collection, reception, storage, transportation, treatment. And this is granted by the state pollution control boards. And this is granted in accordance with the rules framed by the central government or the state pollution control board. So these are the prescribed authorities who grant. The state pollution control boards are the prescribed authority for granting authorization. But in case of armed forces, it is the Central Pollution Control Board, which is a prescribed authority. Now, all this biomedical waste which is generated, collected, needs to be treated, and that is a common biomedical waste facility where it needs to be treated. And because generally, nowadays, the individual healthcare facilities or individual institutions are not permitted or allowed to have their captive treatment facilities. Now, these rules apply to all, as I already mentioned, hospitals, nursing homes, clinics, dispensaries, anything you name, and they are all covered, even the first aid rooms of schools, and which are very, very minor. The generation of biomedical waste is very, very small in terms of number or quantity, but still they are covered. So that means most of the institutes or which are generating biomedical waste are covered. Now, the occupier has certain duties towards management of the waste. And these waste need to be categorized under the 4 categories and has to be filled in different color of bags. That is yellow, red, blue, and white. Earlier, prior to this 2016 notification, there were 10 categories. So now it has been reduced to 4. All the biomedical waste that is collected need to be secured in a safe and secured place so that unauthorized person cannot tamper with that. All the liquid waste that is generated needs to be treated, sterilized, and all the biomedical waste need to be disinfected. The plastic bags no chlorinated plastic bags are allowed to be used. Considering the impact of handling or mishandling of biomedical waste, all the healthcare facility workers need to train their staff and immunize them. The bags in which the biomedical waste is collected needs to have barcoding so that tracking is possible, that where this waste has gone and where it has been treated. The liquid waste need to be treated in conformity with the Water Act 1974. And occupational safety procedures need to be implemented, that is providing the PPEs to the healthcare workers and all this. In addition to this, the occupier has certain additional duties, which includes reporting of any accident, maintenance of all the records of the biomedical waste generation, displaying the data on its website, informing the State Pollution Control Board or committees of the non-lifting of the biomedical waste by the uh, common biomedical waste facility, and reviewing and monitoring the biomedical waste facility activities through a committee which needs to meet. The segregation, packaging, transportation is a very important concept that it clearly says that no untreated biomedical waste will be mixed with other waste. So biomedical waste need to be segregated, as I already referred. The containers or bags should be labeled as specified. There is a system of labeling the biomedical waste bags, and they need to be done. And these bags need to be transported along with the necessary information to the common biomedical waste. The vehicle has to be a specifically designed vehicle for carrying this waste. And the occupier need to ensure that no untreated anatomical waste is stored beyond 48 hours. Some of the salient features of this 2016 rule includes the health check of the facility, workers, improving the incinerator quality, no establishment of captive treatment facility, and day-to-day maintenance of the record of the biomedical waste generation. So the labeling of the biomedical waste has to be as indicated here in the slide, of providing all the detail, waste generation category, everything has to be specified. And then this waste need to be treated depending upon the bag in which it is collected. Yellow bags contain human anatomical waste or soil waste, expired medicines, chemical waste. They need to be treated in a different way. Bottles, tubings, etc. need to be collected in red bags. Sharps, needles, syringes need to be collected in the white bag, and broken glass bottles and other things in the blue bag. And they all need to be treated in different ways. The yellow bag, which contains the anatomical waste, the dry, expired medicines need to be either incinerated or plasma pyrolysis, and the expired cytotoxic drugs need to be returned back to the manufacturer. But it has to be ensured that no chlorinated chemical disinfection is used for the material which is to be incinerated. And red bags containing the plastic tubes, etc., need to be autoclaved or microwaved and sterilized, and then mutilated and maybe given to the plastic waste recyclers. White bags which contain the sharps, needle, etc., need to be autoclaved, sterilized, and shredded before sending to the foundries or the landfill site. And the blue boxes which contain the disinfected bottles, etc., can be sent for recycling. Now, the second major rules which are applicable to many of the waste rules. And these rules apply to the management of hazardous and other waste as specified. As specified means the hazardous waste are defined. What is an hazardous waste? So one thing is hazardous waste are categorized based on the properties, physical, chemical, biological, or the reactivity, toxicity, and flammability, whether they're explosive or corrosive. So this is one thing. Then there are certain wastes which are categorized in the schedule of the management hazardous waste rules based on the concentration, based on the processes. It is very clear that certain processes always generate hazardous waste as a waste, and certain processes will generate waste which may contain certain chemicals beyond a permissible limit, then they are categorized as hazardous waste. Then there are other wastes which are categorized, which are having concentration different as compared to what was specified in Schedule 1, but are also specified in the Basel Convention, are also categorized as hazardous waste also. And then there are certain other wastes which are also categorized, and which are very clearly specified in Part B of the schedule. And for export and import, they may be requiring permission from the importing country or the exporting country, or both, depending upon the toxicity of the waste. Now, as I mentioned that the present hierarchy is waste is a wealth. And what Dr. Pandey mentioned is on the bottom of the pyramid. But if you look at the waste minimization as per the hazardous waste rule or even the solid waste management rule, the priority is on the prevention, minimization, reuse, recycling, recovery, utilization including co-processing. And for hazardous waste, co-processing is one of the major options available, which does not generate any additional greenhouse gas. It does not generate any ash for disposal, because whatever ash is generated, it becomes a part of cement. Any gas which is generated because of the alkaline nature of the material present, it is absorbed. And most of the time, the raw material or the waste is used as an ingredient or as energy. So it helps in recovery of the resources and reduction of the greenhouse gas emission as well as other pollutants. This hazardous waste need to be transported, need to have a certain procedure, which is a manifest system. And under that, number of slips are retained. And at each level, the slip is given so as to ensure that the waste has moved in the right direction and it has reached the right place where it was there, and which is confirmed once the receipt goes back to the generator of the hazardous waste. So they have different colors of the receipt, and white, yellow, pink, orange, green, and every receipt has a different stakeholder which retains that, and so that a proper documentation or record is maintained. Now, storage of hazardous and other waste is not permitted beyond 90 days. And in case there is no such facility, then special permission has to be obtained to ensure that the waste can be stored. The utilization of hazardous waste and other waste as a resource or after pre-processing, either for co-processing or for any other use, shall be carried out only by persons who are authorized, and they have authorization from the state pollution control boards, and in respect of the waste on the basis of the standard operating procedures or the guidelines which are prescribed and framed by CPCB. So all these people need to have authorization for treating, managing, and disposal of the hazardous waste.
So you have 5 more minutes.
Okay. Now the occupier has a responsibility to manage the waste and ensure that all the waste that is generated is collected properly, disposed. And in case of any violation or any accident happening, he is the person who is responsible, and all the liabilities lie with him. E-waste rules are also very important for the new biomed units which are in the functioning or of producing instruments for monitoring of health parameters. And they apply to every producer or consumers, whoever maybe at collection center, dealers, anybody, they apply to that. So e-waste means any electrical and electronic equipment which is listed in the schedule or in part discarded as a waste. So once the definition is clearly defined, so electronic and electrical equipment means equipment which are dependent on electric current and electromagnetic field in order to become functional. So it is very clear that what is constitute and that. So all the electronic waste or e-waste that is generated needs to be managed in an environmentally friendly waste, and all the steps need to be ensured that the way that it is handled, it does not impact the health and the environment. And the producer in this case is the manufacturer and who offers to sell electrical instrument, either in its own brand name or assembled, or it is imported or sold. But he is the person who sells all the waste. Then the Act clearly defined, the rule clearly defined as the bulk users of electrical, which are either central government or state banks, educational institution, which have turnover more than 1 crore or have more than 20 employees. So many of the biopharma sectors may come into that. Now, common facilities are there where all these waste need to be collected, and extended producer responsibility has to be ensured. Is the responsibility of the manufacturer to ensure that the waste, the electronic waste that is generated after end of the life, is collected, treated, and disposed as in a very environment-friendly manner. So, extended producer responsibility is there, which lay down the responsibility and how it is to be handled, and this is the organogram that how it goes. The EPR also defines very clearly a target that how much collection needs to be taken, and by 2022-23, around 70% of the waste should have been collected. The major stakeholder in this are the producers, then the bulk consumers with collections centers, manufacturers, recyclers, Ministry of Environment, which formulate the rules, and the refurbishers, because the collection center, it goes to the dismantlers, the refurbishers, where the material is recovered, recycled, and reused back so that the cycle is maintained. Now, the rules have been simplified. That's a very important that pan-India approach is there. Authorization can be pan-India, and no separate authorization is required to be taken. And the economic instrument for implementation of rules has been there. Interstate transport is permitted, and the liability for any damage lies on the person who generated that. They are the responsibilities of the various authorities, and the producer has to obtain extended producer responsibility, implement the EPR, ensure collection and channelization of e-waste, ensure reduction of hazardous substances in the products, to create awareness and maintain records and file annual return. This is a responsibility of the producer, or you can say the occupier in other terms. And this is why we should not process it in a non-scientific manner, because it has a lot of impact on the health, soil, and ambient air. So this was in a very brief nutshell of the various rules which are applicable to the biopharma sector, including the biomed facility as a startup. Thank you very much.
Thank you so much, Kamyuta Saab, for very comprehensively giving overview of regulatory requirements and what are the requirements which industries need to plan for, especially useful for startups or those who are willing to come into this business of manufacturing or processing. And I'm sure there'll be a lot of queries at the end of the session when we open it for Q&A. Dilip, will there be poll?
Yeah, we have a poll question for the participants. So the poll question will be shared on the window, and you will be getting 30 seconds to answer that. Under which environmental act the Biomedical and E-Waste Management Rules 2016 are framed? Environmental Protection Act 1986, Forest Conservation Act 1980, Water Prevention and Control of Pollution Act 1974, Air Prevention and Control of Pollution Act 1981. So we will be having 10 more seconds for the poll, and after that we will close it. So as you can see, 92% of the participants given a right answer. Environmental Protection Act 96 give this for biomedical waste. Over to you, sir.
Thank you, Dilip. And that showed that all the participants were mostly very keenly listening to the presentation by Mr. Kamyuta, which is a good sign. Our next speaker is our next speaker is from the waste management industry, and he's Mr. Sajid Sadevan. I hope I pronounced it right. Mr. Sadevan is a chemistry graduate from University of Calicut. Around 32 years of experience, though he doesn't look so old, in API intermediate manufacturing and related operations. Started his career with Cipla Bangalore, and worked for almost 6 years with Cipla, and was involved in API manufacturing, quality control, and quality assurance. was also with Sequence Scientific Limited, Mangalore, a sister company of Strides Arcolab from 1994 to 2007. Was involved in chemical synthesis, so has adequate exposure to plant operations, CHS, and project executions, and has now joined Anthem Biosciences from the inception year 2007, and has been heading EHS department at Anthem. Over to you, Mr. Sadevan, for your presentation on waste management in biopharma units.
Thank you, Dr. Sunil, for the introduction. I'll just go on to my screen.
Yes, go ahead. We can see your screen.
Yeah. Good afternoon, everyone. My name is Sajid, and I'm from Anthem Biosciences. As a part of this webinar, I'll be providing an insight into the treatment of aqueous waste generated during the operations in a biopharmaceutical plant. At the onset, let me introduce you to Anthem Biosciences. Anthem Biosciences is a company situated out of Bangalore, incorporated in the year 2006. We started operations in the year 2007. We provide services in research, development, and manufacturing of APIs, intermediates, and chemicals for varied applications. We are an employee strength of about 1,300 people, most of them being scientists. We cater to major pharmaceutical companies, biopharmaceutical companies, agrosciences, and biotech companies worldwide. Now, moving on to the core topic of the day. First, let us understand the different types of aqueous waste which is generated in a biopharmaceutical operations. First, we have something what we define as a lean aqueous waste. The lean aqueous waste is something where we see the chemical oxygen demand is in the tune of about 10,000 ppm, and the total dissolved solids would be in the tune of about 4,000 ppm. This definition of the lean waste is something which we have defined internally. But by our experience, we know that this is the type of contaminations which would be there in the lean waste across the biopharmaceutical sector. This type of waste is normally generated from the washings of the process equipments. It can also be generated from the process itself. It can also get generated from the flow washings. The other type of waste which we will be discussing about would be the aqueous waste, which we define as the high TDS, high COD. The COD in these cases can be upwards of 30,000 ppm to all the way up to probably 2 lakhs or more. The total dissolved solids in this type of waste would be in the range of about 10,000 ppm to nearly 50,000 ppm or slightly more. The third waste which we would be discussing about in my presentation would be the spent cell mass. This is the waste which normally gets generated from a fermentation process. Now, before we go ahead and understand how we treat these various types of waste, it would be interesting to understand how this gets generated from the process. For this, I have made a brief process flow diagram. And let's get started with a fermentation reactor into which we would have various ingredients going in, typically water, which is used as a medium, other reagents, cultures, all this would be fed into the reactor, and the reactions would be carried out as per the batch manufacturing record at the stipulated parameters for a stipulated time. At the end of the reaction, we would prepare for the downstream operations, which would typically be filtration. Once all the engaged reaction mass are filtered, the empty reactor would be subjected to cleaning. This is where the first lean aqueous waste gets generated. From the filter itself, you would have a spent cell mass coming out, which is the second category of waste. which needs to be decontaminated before it's sent to ETP for further treatment. The aqueous filtrate, which comes out of the filtration process, I have considered it being taken up for ultrafiltration. And the permeate which comes out of this would also be classified more or less as a lean waste. The product which would be in the retentate would be in a concentrated form in the aqueous media. Now, our objective is to try to recover the product from the aqueous. So one of the procedures adopted would be extractions. For this example, I have considered ethyl acetate as a solvent being used for extractions. As a normal practice, to enable proper extractions, we normally use some form of salts to saturate the aqueous layer before we use the solvent for extraction. So at this stage, what happens is the product which was initially in the aqueous layer would move to the more polar solvent ethyl acetate. At the end of this extraction, the aqueous layer which would remain back would be a waste, and this typically would have high salt content, and it would also have high chemical oxygen demand because of the influx of the ethyl acetate into the aqueous layer. Ethyl acetate has about 6 to 7% solubility in water, so part of the ethyl acetate would move into your water layer, rendering it high COD. So these are the various streams which gets generated during the process. Before we move forward to see how this gets treated, let's quickly look at what happens to the product which is there in the ethyl acetate layer. This would typically be taken into a reaction for concentration, at which stage you would get ethyl acetate recovered, which can be recycled and reused. The concentrated mass gets filtered, and you would end up having your product in a wet cake form, which can be taken up for either further purification or for processing. The mother liquor would typically have ethyl acetate, which would be taken up for recovery and reuse. So this gives you an overview of the type of waste being generated in a typical process being followed in a biopharmaceutical plant. Now, having understood how the waste is getting generated, let's look at the operations in the ETP for treating these. The objective for the ETP operations for treating the effluent, aqueous effluent, is to ensure that we, at the end of it, we get a water which is good enough for recycling in the plant itself. This would entitle reduction of the chemical oxygen demand to less than 50 ppm and the dissolved solids to less than about 100 ppm. The treated water gets recycled mostly in the utilities in the industries. The utilities being boilers, cooling towers, scrubbers. It can also get utilized as toilet flushes. The ETP operations involving the treatment of this aqueous waste can be broadly classified into 3 sections. The primary treatment is more of a preparatory work. The secondary treatment is the core of the treatment, and the tertiary treatment is more of a polishing treatment. Now let's get into the nuances of the primary treatment. The lean effluent which comes into the effluent treatment plant would have a lot of extraneous materials like bottle caps, plastic straps, polybags, pieces of gloves, papers, etc. It would have traces of oil and grease. It would have suspended solids. The pH would be ranging anywhere between 5 to 9. And the COD and the TDS would be about 10,000 and 4,000 respectively. Now, in the primary treatment, we target to address the first 4 parameters. After the primary treatment, we would have ensured that all the extraneous materials are removed. The oil and grease would be reduced to less than 10 ppm. The suspended solids would be reduced considerably. pH would be adjusted to the range of around 7.5 to 8.5. Nothing much gets done on the COD and the TDS during the primary treatment. The components of an ETP are as follows. We have a bar screen and an oil and a grease trap. And as the name suggests, this is basically to remove the extraneous materials and the oil and the grease. After which, it moves on to a neutralization and an equalization tank. And then further on to a flash mixer and a flocculator, where the suspended solids are flocculated and coagulated, and then carried on to a clarifier for settling the suspended solids in the flocks, which is the supernatant, from where moves on to the balance tank for further treatment. I have provided you some images of some of these components. This is the bar screen. There are various types of it, but this is the one which we are currently using in our site. This is the oil and grease trap. We have the effluent coming in from the furthest end. It moves in through a lot of chambers, which is baffled, and then comes to the middle chamber where the oil floats onto the top, which is removed by a skimmer, oil skimmer. And this water, after the oil is removed, goes on to the neutralization and equalization tank, where you have a hydraulic retention time of about 8 to 12 hours. The pH is adjusted before it is sent to the flash mixer and flocculator for removing the suspended solid. Within the primary treatment, flash mixer and the flocculator, or the flocculation and the coagulation, is a very important step. Most of us tends to neglect it or tends to get things wrong over here. This is a step where the suspended solid gets effectively removed. For this, we use a lot of flocculants and coagulants like lime, alum, polyelectrolytes, and many such things. But the objective is to get a very clear supernatant at the end of this operations and to remove the suspended solids in the form of flocks. Now let us get to the primary treatment for the high TDS and the high COD effluent. The high TDS and the high COD effluent also has a similar characteristics as the lean TDS, lean effluent, other than the fact that the pH would be very high. The range of the pH would be from very acidic to from 2 to a very alkaline to 12 or more. The COD also would be very high compared to a lean effluent, and it would range upwards of about 50,000 ppm, and the TDS would also be upwards of 10,000. At the end of the primary treatment, like in lean waste, we basically remove the extraneous materials, the oil and grease, reduce the suspended solids, and adjust the pH to 7.5 to 8.5 before it's taken for the secondary treatment. We don't do much for the COD at this point. There could be a marginal reductions, but we don't do much for the reduction of COD at this stage. The components for the ETP for the primary treatment was shown earlier for the lean waste. We have a similar setup for the high TDS waste, except that after the clarification, the supernatant gets collected in a tank, which is taken to a distillation column to remove the volatiles, which could be the solvents like ethyl acetate, acetone, methanol, or anything which comes out from the process. This gets removed in the distillation column with traces of water. And the bottom of the distillation column, you would have an aqueous layer which is high in dissolved solids. So this is taken to an equipment called a multiple effect evaporator to effectively remove the water, to basically to distill off the water. Multiple effect evaporator is a component, is an equipment which will ensure removal of water very efficiently. Theoretically, 1 kg of steam would remove about 1 liter or 1 kg of water. But by using the multiple effect evaporation method, we will be able to remove or distill close to 3 to 5 kgs of water using about 1 kg of steam. So it's an energy efficient equipment for the distillation of water. The concentrated aqueous waste, which comes out of the multiple effect evaporator, is fed to the agitated thin film dryer, from which we get the dissolved salts, and the condensate is taken back to the balance tank for further treatment. So at the end of this primary treatment, we would have a CODs roughly in the range of about 10 to 15,000. TDS would be, TDSs would have come down substantially to around 4,000 ppm. There could be an ammonical nitrogen in the process. Ammonical nitrogen tends to come into the process when we use ammonia or amines in our process. Total ammonical nitrogen is also expected to come into your effluent stream, especially if you're using a fermentation process. And it's very important to ensure that we treat this adequately. The oil and grease would be less than 10 ppm. The turbidity would have come down substantially, and the pH would be in the range of about 7.5 to 8.5. So we are ready to take it to the next step, which is the secondary treatment. The secondary treatment, you have something called as an anaerobic digester. We use an upward anaerobic sludge banket reactor. And in the whole ETP process, the anaerobic digester is supposed to be the most energy efficient and most productive stage. The COD reduction across the anaerobic digester is in the tune of nearly 60 to 70%. But the flip side is that this is a very sensitive operation. We primarily depend on the cell masses or the microbes within the anaerobic digester, and they are very sensitive to a whole lot of parameters, and we need to monitor the pH, we need to monitor the COD reduction across the stream, we need to monitor the quantity which is fed, we need to monitor volatile fatty acids, we need to monitor the alkalinity, and we also need to monitor the biogas which is generated to ensure that the health of this digester is maintained and sustained.
So the anaerobic digester, you have another 5 minutes.
Okay, I'll rush through. The anaerobic digester typically has a sludge banket and a gas liquid separator. The gas liquid separator helps to remove the biogas, which can be collected in a biogas holder and which can be used as the fuel for the boilers. This is the component. This is a byproduct which is very valuable because it has got a high calorific value and is a fuel source for the boilers. After the anaerobic digestion, the water flows into the anoxic tank and then to the aeration tank, where the reduction of the COD takes place, the further reduction of the COD takes place, and this treated water is finally removed through, in our case, through a membrane bioreactor, through which we get the clear permeate out, and the sludge is sent back for recirculation into the anoxic tank and the aeration tank. This is an overview of the anaerobic digester, the aeration tank, and the MBR tank which we have. Besides using the MBR after the aeration, there are also systems which can use clarifiers also. But from our experience, we have seen that the output of the MBR or the membrane bioreactor is much more clearer, and we would highly recommend using this. So at the end of the secondary treatment, we would have removed oil and grease, suspended solids. The pH would be 8.5. The COD would have reduced substantially to 250 ppm, but the TDS would not have got reduced because nothing gets removed. The TDS part does not get handled in the secondary treatment. Now we come to the tertiary treatment, which is more about polishing. There are two options available here. Either we use a sand and activated carbon and hypochlorite. Sand removes the suspended solids. Activated carbon can remove some traces of residual COD. Hypochlorite helps in disinfection. But the more Sturdier option would be to have a reverse osmosis systems, which helps in reduction of COD substantially from about 500 ppm to less than 50 ppm. But most efficiently, it reduces the TDS, which can be brought down to about 100 ppm or less. So at the end of the ETP treatment, we have a COD reduction to less than 50 ppm and a TDS which is less than 100 ppm, which is good enough for use and recycle in the utilators. Coming to the spent cell mass, the spent cell mass has two options for treatment. The decontaminated cell mass which we receive from the operations either can be concentrated in the multiple effective operator or the agitated thin film dryer, and the dried mass can be used as a composting material. This is a non-hazardous waste. Alternatively, what we do at our place is we have designed and using an anaerobic digester for the digesting the cell mass. So we get biogas as a byproduct out of this, which is used in the boilers. And the digested outlet is filtered to remove suspended solids, which is used for composting. And the aqueous waste is taken for biological treatment. My last two slides has some facts and figures on the costs of operation and the capital cost of investment for putting up a 150 to 200 KLD ETP in a typical biopharmaceutical application. These are very tentative costs, and just for information, this could be subject to a lot of changes depending on how you want to go about doing it. So the supply of installation of biological system includes the entire system, including the MBR, the sludge dewatering unit, the electrical, the piping, and all those things. Distillation column, multiple effective operator, and agitated thin film dryer of a 60 KLD capacity would roughly cost you about 315 lakhs. The RO system, which is used as a tertiary treatment, would cost you upwards of 60 lakhs. My final slide is on the cost of operations. The biological treatment of lean aqueous waste. This is again is just as an information. This could change a lot from places to places and depending on how efficiently you do it. The distillation and the ME and ATFD cost is depending on the cost of steam, because this is the single biggest largest contributor to the cost over here. I have considered for my costing a steam at roughly about 3 rupees per kg, and the cost of landfill, when you give it to the outsource it to the vendors, at our end, it really costs about 6,000 rupees per ton. But this is also a huge variable. So that's all I have to share with you. Hope the information provided has been helpful. And over to the Dr. Pandey.
Thank you, Sajid, for a very interesting presentation on how aqueous phase of the waste from the biopharma industry can be handled in an integrated manner, and also how it is possible while meeting regulatory requirements also to do some energy recovery, which can feed back to your energy requirement in the process. Thus, we can reduce the cost of treatment, offset some cost of the treatment. I'll hand it over to Dilip for the poll question, and then we'll go for Mr. Patil's presentation as a third speaker.
Yeah, thank you, Dr. Pandey. We are having two questions with Dr. Sajid, and the first question is coming in your screen. What is the objective of treatment of aqueous effluent generated from the operations? Regulatory compliance, conserve natural resources, contributing to sustainable development, all of them. We will give 30 seconds for the participants. So all of the above answer, around 90% of the participants answered this question correctly. And the second question comes, besides treated water, what is the most valuable byproduct obtained from the ETP operation? ETP sludge, salts from multiple effect evaporator, biogas from anaerobic digester, spent oil recovered from oil and grease trap. So, as most of the participants answer is biogas from anaerobic digester is the correct answer. And we'll be having the third presenter. Over to you, sir.
Yeah, thank you, Dilip. And I'm very glad to see very informed participants and also making right decisions in the poll questions. Our third speaker also is from the biopharma industry sector and has been engaged in uh, uh, biopharma waste management. And let me briefly introduce you to him, Mr. Rajendra Patil. Over 2 decades of experience in areas of health, safety, and environment, and strong EHS professional. And he brings with him in-depth understanding of various safety and EHS practices, as well as has expertise in conducting HSE audits, risk assessments, implementing right control measures to achieve high HSE standards. He has been associated with various organizations, including Nippon Denrose Path, Merin Limited, Sandoz, and Syngenta. Currently, he is working as a head of EHS in Syngin International Limited, leading global scale scientific service provider, where he is responsible for advising Syngin for adopting best environmental health and safety practices. He holds his master's degree in environmental engineering from PDA College of Engineering, Gulbarga, and has done advanced diploma in industrial safety from Institute of Safety Professionals of India, Mumbai. So over to you, Mr. Patil, and you have 15 minutes to engage the participants.
Thank you, Dr. Pandey. Dilip, are you sharing the slides? Give an invitation to share.
Yeah, yes, sir. So you have the command, sir.
Must be share your screen option.
Share.
Dilip, I think you will be unsharing this Sajid's presentation before.
Yeah, I guess you have the command, sir.
Yeah, sure.
Able to see my screen?
Yes, yes, sir.
Yes, we can now.
Okay, just let me. Okay, I think I must thank the panel lead Kaminyotra, Sunil, and Dilip for giving me an opportunity to talk on this subject. As I see my time and get corrected, it last 10 minutes as per at the end at 4:45. But what I will do is, as my previous speakers have already dealt enough in legislations, enough in what is good to environment, in even Sajid Sahadevan also talked about wastewater management and the value coming out of wastewater management. So I am looking for the participant, as an employee wherever you are engaged. There's an EHS department generally deals with the waste management, but you have a major role to play as an employee, as a citizens of the country or the locality, because environment is something wherein it is very sensitive, and whatever we do today, doing right things, it will at least give the result to take another 50 years to come, because what we're facing today is all that ill treatment we have done in the past 100 years or 150 years. So in the environment scale, it's actually a long time, but we have to do it every time the right thing. So at the end of my presentation, you will be coming to know how pharma industry categorizes the waste. Then what is the waste flow? Generally, it has. I'm coming basically from waste management as a solid and a liquid, not from a effluent treatment plant and a gas treatment and all that. And also finally, how Syngin is coping up with the COVID waste management and COVID situation we're all into today. Now, as you all know that Kamiotra has very much dealt with the legal requirement. At Syngene, we have an integrated waste management philosophy. We have a hazardous waste categorization as per hazardous waste. I'm not going deep into the schedule one, which talks about process based. There is schedule two, talks about concentration based, categorizing the waste. We also have some non-hazardous waste generated in the biopharmaceutical industry. They are basically coming from the changes we are making in our facility, the construction, the demolition. That also will generate some waste. That comes on solid waste management. As you are aware, being a research organization, we do handle radioactive compounds. These radioactive compounds are basically are enacted from atomic nuclear power plant and research institutes where they use radioactive material. We'll also talk on that. Yes, of course, we dealt with e-waste management in enough, and biomedical waste was also dealt very clearly with my previous panel member. Now, I would say that your involvement as an employee is very much important in collection process of the waste. Various wastes have been categorized. They are required to be segregated at the source, because if you don't segregate at the source, then it is going to be a big task at the end of the line how to segregate, how to find a scientific disposal of each of the waste which has been generated. So your input here would be, ask your people, ask your EHS department where and how we should segregate the waste at the source. That is one of the way you are creating a value into managing waste efficiently. You are also important to label the waste. You know that every creature in this world has some labels, right? We have been humans with our own names, like I'm a Rajendra Patil. Similarly, deal with waste with the labels. If you put the labels, then the processor will know what it has inside, how safely it can be produced without damaging environment. And of course, don't forget, it all these rules coming up. Finally, we have some clearance authority coming for, okay, it is okay to dispose it scientifically, either incineration or recycle or reuse. So authority also plays an important role as in giving permission timely to dispose it. If I don't get permission, then I'm creating a situation which is not safe, keeping chemicals which are beyond their life span. Then also, while you are handling this waste, a solid and sound construction waste yard is required, so that it doesn't pollute locally, it doesn't pollute groundwater. Your involvement as an employee, please go back and visit your waste storage facility in your premises. Ask them, is there anything not being done as per scientifically sound construction, sound management? Please ask them to do that. Then comes finally, we are to declare some wastewater moving as per hazardous waste management or transport rules. There are manifestation forms, and also as the manifestation form becomes a legal requirement, prior to that, it is important that we level the waste, we maintain the internal waste manifest, so that there is a tracking system available, which department, which batch, which where this waste has been generated, how many days it has been lapsed of generation, and you know that the requirement to not to store more than 90 days, then all that become a legal requirement. So have a foundationally a good labeling system, a good internal waste manifest system, so that you are in control of the waste. Of course, there are scientific disposal, what we call as a treatment, storage, and a disposal facility. There are also possible recycling, and also if there is no alternative for treating and recycling reuse, then comes an incineration. We don't propose going for a landfill for the chemical waste, for that waste which are basically going to liability for the future. Don't propose that. And of course, pharmaceutical industry has categories of waste to be generated. They are listed there. I'm not going to that. One more thing again is also an important aspect here is, as the technology is developing, in 2001 we had this lead acid battery rules. Now there's a recent amendment which is coming of battery rules 2020, because technology also giving off a new waste, and that is also posing us into end user responsibility, extended liability of the producer, and all that becoming a part of the rule. But as a citizens of this earth, I would urge you to do your best part to segregate, dispose it with the right vendor so that you are protecting the way you want in a small way to protect the environment. That will be your contribution. Now, going for a non-hazardous waste, of course, yes, there's something we call is a food waste, glass, metal, paper. That is where your important role is to identify, segregate, and don't mix it up. The more you mix it up, the more problem we're creating ourselves to disposing it scientifically. So then I will talk a bit on radioactive waste management at Syngene, wherein we have some applications wherein we require some radioactive isotopes to be used, especially tritium, H3, iodine, and P32. These are used for in vivo and in vitro studies with animals, and the liquid waste generated out of these is disposed as per AERB guideline. AERB stands for Atomic Energy Regulation Board, and the solid waste generated, as you are aware, the radioactive waste has fundamentally three radiation: alpha, beta, gamma, and each of these radioactive waste have their half-life period. Accordingly, which are beyond certain time are stored into lead treated tanks, which is basically 12.5 years of half-life. There is something which can be stored in a normal RCC tank with the 65 days half-life time. So we have all those facility available in Syngene, which are approved by government regulation, ARB guidelines. Those gets into proper containment, segregation. Then we compact those waste because there is no treatment for them as of now. We are just keeping it into a dedicated scientifically designed tank so that the only disposal is deep sea burial for radioactive waste, but we have enough space created for next 10 years so that first of all, we should not generate. Even if you generate, there is sufficient space available for radioactive waste. Then comes e-waste management. We talked very lengthy on that. Remember, e-waste is something, it is includes even the electrical waste. Even the telephone is your e-waste. The computer systems are, the parts are e-waste. Imagine if you don't dispose it with the right recycler, then it has all those hazardous toxic chemicals inside into that, which will create a liability for the generation to come. As a individuals, as a corporate citizen, you have to do is at the end of the use cycle, dispose it with the right recyclers, right user, even electronic waste as well. So biomedical waste, we had a big, talk by Kamyotra. Thank you, sir. You have explained it very well. We have 4 categories of hazardous biomedical waste generated. Each of them are packed in certain colors. And I know there is also regulation by central CPCB regulation to have a barcode for tracking biomedical waste. And this is one sample I'm giving you. We have engaged Meridi Eco Industry as one of our disposal facilities approved by State Pollution Control Board. It has a scanner so that we can track the biomedical waste generated. So at Syngene, just to brief the participant here that ICMR has approved COVID-19 ELISA antibody, a test kit which was developed by Syngene. And Syngene has set up its own approved facility for RT-PCR testing. We have a laboratory here. The waste is generated in this laboratory. And we crossed almost 50,000 tests very recently. And take it as a standard practice that all that is dealt safely there. The contaminated waste is treated, and there is a dedicated transportation disposal approved by KSPC is also as a part of that management. So I'm end of my presentation. So in an onset of COVID, I'm talking about in March or April, Syngene took early leaps into on information awareness on COVID. We developed a microsite where employees feed in their daily temperature. There's a continuous information. Then also we were giving the briefing to leaders, town hall, so that the vaccine available for us is safety distancing, using mask, washing hands. Then we also didn't differentiate employees and contractors. They were oriented, the emergency services, cafeteria, deep cleaning were part of our employee contractor protection. As a business continuity plan, when the national lockdown was, I would say, declared, we had a process of shutting down the system where the risk is involved. And also then later when the lockdown was lifted, there's the process of starting up the facility. So we covered it very well with the coordination with all the stakeholders, engineering maintenance, users, EHS, supply chain. Holistically, all of us have come together to considering this crisis as a normal way to deal with that. And also, we're also having the tests and treatment and vaccine also being worked by Syngene with that. So these are some glimpses where the transportation was taken care, where the vehicles were sanitized, the temperature monitoring. One of the system we introduced on the Biocon Park site is we are on 20-25 buildings. Each of the buildings, the clusters of buildings were categorized into number of zones, which will help us to not to cross the zones, which will easy for us to from primary contact tracing and secondary contact tracing. Is something wherein we introduced from day one in the month of April, something which gives us a feeling that in case a positive case goes, how to deal with that zone, how to deal with that building, so that we introduce the tier 1, tier 2, tier 3 kind of sanitization. So giving that employees is a center point or the contractors are center point of maintaining their health in a workplace. So this is my last slide. Just want to update the participant here that Syngene has a track record of 26 years of solving complex R&D problems. We are a global CRO. We have an IP protection position, a scientific ecosystem, Bacon Park, 4,200 qualified doctorates and scientists working here. We have around 362 clients globally. And most of the major clients are pharma companies globally are engaged with us for doing research and contract manufacturing. We are quality focused, and our track record says that the collaborators would love to work with us. So thank you very much for giving this opportunity. I think Sunil, I did my best in given 10 minutes slot, Sunil. Thank you very much.
Thank you, Mr. Patel. I really appreciate that. And very interesting aspects also. Key to your presentation was that label properly, segregate properly, waste properly at source, and that can actually solve a lot of your waste management problem. And also a very unique aspect of how low-level radioactivity waste, which are generated in some of the biopharma sectors, can be managed, can be safely stored till the radioactivity decays to the level where waste can be disposed. I hand it over to Dilip for poll question for Mr. Patel's session, and then we'll go back to quick Q&A.
Sure. Thank you, Dr. Pandit. So we'll be having two poll questions here. So the first question is in your screen, that is biopharmaceutical industry generate following waste: hazardous waste, e-waste and solid waste, biomedical waste, and all of the above. We'll be giving 20 seconds for this question. So we have the answers here, and all of the above is the answer, and we are having the next poll question. Electronic waste are following: discard laptop and its part, discard telephones, primary package of electronic goods, only A and B. Here also we'll be giving 20 seconds. It's rather an easy question, and 95% of the participants given the correct answer. 95, it is only A and B. Over to you, Dr. Pandey. We'll be having the panel discussion now.
Thanks, Dilip. And what we'll do is we'll take a Q&A session, and I'll kind of look at questions. And many of these questions, which were pre-webinar questions, I hope are already answered by the three panelists who covered wide range of policy, rules, regulations, waste management, actual waste management site, and what are the technology options. Uh, 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 One typical question which I would like to pose to all the three panelists and whosoever wants to answer that is what is the SOP for disposal of thermocol boxes after receiving contagious samples and once they need to be discarded. So anyone from you can take charge on this.
I think, sir, I will go for this. Try to answer this question. The thermocol is something where is a bad waste invented. I would say that, and it has a high, I'd say, large time of biodegradability. I don't know, more than 1,000 years or something like that. And it is not suitable either for a landfill, either for nobody want to recycle use it. So what you have done in the past is the only way is it has some calorific value. So it can go with cement co-processing as a fuel or incineration, Dr. Sunil. This is my...
But it is actually used for packing contagious material. So would you like to decontaminate it in some manner or sterilize it before you process it?
Exactly.
Okay. Because what interestingly, I mean, what we have been seeing, we also have been working with Goa, Panjim city in that sense. So what municipal corporation there is doing is shredding these thermocol packaging into smaller pieces. And then there's a market apparently for using it for construction applications. For example, Sajid, where he's sitting on top, you'll see those false ceiling. Some of these construction applications can be made using shredded thermocol pieces once they are sterilized and not contagious.
Yes.
Another question.
That's an interesting information.
Want to add anything?
No. That's an interesting information which we can work on.
Sure. Another interesting question, which probably Sajid also touched briefly. I don't know if that was really relevant to GMOs. Is how to manage large volume of effluent coming out from GMO fermentation process.
Okay, see, we do not handle GMOs in our current facilities, so I would not have a first-hand, information on how do you handle it. But most importantly, it has to be ensured that it is decontaminated at the process stage itself before it is sent to the ETP. Because once it comes to the effluent treatment plant, we do not have very high-end people over there, and it gets mixed with the whole lot of other effluents. So it's a primary responsibility of any scientist or operation person to ensure that any hazardous materials or toxic materials like this gets decontaminated at the source itself. There are many ways to decontaminate cell masses and things like that. You can use alkaline conditions, you can use high temperatures, you can use hypochlorites, and there are many other disinfectants which you can use, but it's very important that it gets decontaminated before it's let out for the treatment at the ETP.
Thank you, Sajid. Dr. Kamyotra, are you there?
Yeah, can I add?
Yes, sir.
To what
especially, I mean, GMOs, as you know, can be released into environment. So what should they be doing if anyone is using GMO?
Can you repeat, Dr. Pandey?
So the question is how to manage large volume effluent coming from GMO fermentation process.
Yeah, what Mr. Sajid mentioned, it needs to be disinfected. And the main problem, what I have seen while going through all these sectors, there is no testing done whether the disinfection has reached that stage or not, which is prescribed in the biomedical rules. That if you are doing it using a oven or anything, the temperature has reached or not, whether the log disinfection has attained or not, no testing is done. That is one of the major missing part, which I have noticed. And second thing is that they have a lot of active cells sometimes in the air also, and for which testing is done regularly in the laboratory. Regularly, the plates are there, but the data is available after a certain gap of time. because no online system is available. So
Sir,
by the time the damage can have been done. So
third
there is a
question
need.
also. Thank you,
Yeah,
thank you, sir. Third question also is for I think you to answer. Implementation of standards for concentration of antibiotics found in waste discharge by pharmaceutical factories.
Yeah,
Residual antibiotics.
so far we have it has not been done, but the work has already started, and some attempt was made recently in the draft standards for the pesticide and pharma sector which were there, but certain observations have been raised. So that's why in the EC initially there was a process that in case you change the active pharma ingredient API, you are not allowed to change the process unless you get the EC. But now that has been slightly relaxed, and if the production quantity is not increasing and other things remaining same, the API can be change in the API can be permitted. So standards per se for each sector has not been formulated so far, and the work need to be done in a big way.
Sure. Thank you, Mr. Kamitha. Next question is basically to our panelists, Mr. Patil and Sajid. What is waste management process protocol for completely used chromatographic resins?
Can you just repeat, please?
Basically, what's the management strategy for chromatography resins which are completely exhausted and they have to be discarded?
These wastes normally we collect it and we send it for incineration. This is what we do at our end. I don't know if Patil can put some insights in this.
No, in fact, these resins need to be tested for the mass-based concentration. What is that it has? Whether it has some kind of metals or poisons. Accordingly, one of the best ways whether we can recycle. If not, then as Sajid is telling, we also do an incineration of this waste.
We're also looking into the possibility, Dr. Pandey, we are also looking into the possibility of co-processing this because chromatography normally uses silica. We use a lot of silica for column chromatography, and silica is nothing but sand in a manner. So we have had testing done with our co-processing units, and they are willing to accept this, and we made an application to the Pollution Control Board to permit us to send this for co-processing.
So there's a possibility of regenerating these resins.
No, I'm not talking of regenerating of the resins. I'm talking of using the spent silica which comes out of the chromatography for co-processing.
Co-processing with cement. Yeah.
But is there a possibility that your supplier takes it back?
No, because you have a lot of impurities embedded into that silica or the resins what you're talking about. So it's not possible to ensure that we completely remove the impurities out from this, solid phase, this one. So it would be a risk, especially when you're doing high-end APIs. So the contaminants which can be carried forward is a high risk. So one would not risk doing that.
Okay. Thank you. And
Dr. Pandey, I'd like just to add for information of Mr. Sajid that
yes,
since no testing has been done for the silica in the co-processing, so the first trial need to be approved by CPCB. So kindly ensure that, the procedure is to be followed by CPCB, guidelines have to be framed, and then only the state boards can permit regular co-processing of the silica waste.
Thanks for reminding that, sir. Anything as a trial, first CPCB has to approve. With trial run of 500 tons or a 200 tons test sample emission tested, then that becomes a protocol to be followed by other state pollution control board. Thanks for reminding that, sir.
Thank you, sir. And another question, and this is the last one because we are already running late in the session, is related to what Sajid presented, how to discard mammalian and microbial cell cultures.
So as I had explained, there are two ways. First, it has to get decontaminated, and either it can be concentrated, using the multiple effective operators and then an ATFD, and the concentrated mass can be sent for composting. It can be dried, and that can be sent for composting. Alternatively, what we have tried out in the large scale is we take it into a digester which has been designed specifically for digesting the cell masses. So we have this biogas which is getting generated from this anaerobic digester, and which is used as a fuel, as I mentioned earlier. And then what comes out of this digester is very inert, materials, which most of it would get digested, and you would have the liquid with a little bit of suspended solids which is coming out, which gets filtered. The liquid goes for treatment in the biological plant, and the suspended solids can be used as a composting material.
Sure. And just to add that to that properly, if you're not generating enough amount and if you don't have digester in your treatment facility, smaller amounts can also be, after decontamination, composted as a possibility. So that
Sure, this can be done, certainly.
So in that case, Dr. Pandey, it can, after disinfection or sterilization, this can be sent to the common biomedical waste facility in the yellow bags.
Yes, even that.
But I don't think it needs to go into biomedical waste, this particular one, because this is as far as
for small, very small units, we don't have the facility to treat it. But what they are doing today, they are flushing it to the water, actually. So, yeah, so it will be a better way rather than to control it.
Okay.
Thank you, thank you, sir, for updating us. So with this, I'll close the Q&A. Very interesting session, and a lot of interesting questions also raised by participants. And I hope you are satisfied by the answers provided by our experts. And over to you, Dilip.
Thank you, Dr. Pandey. And I request all the panelists to just switch on their camera for a minute or so that we can take a group photo for our social media platforms. And we are actually very fortunate. We're happy that all the panelists given their presentation, and we are very thankful for them. And I thank all the attendees also for their valuable time. And we are actually halfway through our webinar series on environment, health and safety. So we completed the third one. So the fourth webinar on the series has been listed on 12th November 2020. And the information about that webinar will be listed on our website in a couple of days. And the webinar will be based on building a safe and resource efficient laboratory. So we already listed very eminent speakers. We have very eminent academicians. We are having industry experts, and we are having the policy experts for this webinar. I hope that we will be meeting them, all the attendees for that meeting also. So thank you, everyone. Have a good day again. Thank you all the panelists one more time.
Yeah, also a big hand to our speakers.
Thank you, Dilip. Thank you, Kamathya sir, and thank you, Dr. Sunil Pandey. Nice meeting you up over here. Rajendra Patel, I keep meeting him occasionally.
Yes. I must thank Dilip to start with, and Sri Kamiotra, then Sunil Pandey. We have extended relations now, because the world get lost when we move from one or other organization. So I'm happy to continue connections, see that what way we can help in sharing our learning and experience. Thank you very much.
Same here, and I'll request Dilip to gather the feedback of participants, and if there is anything which we can look at